Hello students, in this section we are going to deal with a topic named regulation. Regulation can be defined as the phenomenon in which the freezing point of water is lowered by the application of pressure. I have already pointed out this before. I gave you an example. You take ice and take ice at -4 degree or -5 degree Celsius, and then take a knife and press the ice hard. The point where you are pressing, at that point the ice will start melting, because when pressure increases the melting point will decrease. So ice melts at lower temperature when the pressure is applied. Now after this, so let us see some more thing. So here I have given an example, a girl skating on snow. I will come to this example later. Just see this. Just see this example. First let us discuss about this and then we will go to that skating part. Imagine I have just kept two masses, two metallic block, and a block of ice is kept, and there is a copper wire and two masses are hung on the copper wire. That is what the figure is. So due to this mass, which I have marked in green color, due to this mass there is a pressure acting on this region of the ice block. So ice will start melting only from the point where that copper wire is lying. So ice will melt and the copper wire will slowly move down. Okay, it will move pass through the ice, and finally the copper wire along with the mass will fall down. So what happens to the ice? You will think ice will become two parts, right? Because copper wire is passing through the ice is melting and the copper wire is passing through the ice and the wire is falling down. So the ice will become two parts, that is what we think. But ice will not split into two parts, ice will remain as single piece itself. Why? Because when I applied the pressure here, the ice melts and the copper wire went through it. As the copper wire is passing through it, the pressure became normal. When the copper wire passes through that ice, on the top of that the pressure became normal. And what is the temperature of the ice I took? -5 degree. So the ice melted when the wire passed through it, when the wire passes by, and as soon as the wire passes, the water will refreeze back to ice. Okay? So it passed through the ice, it gets refreezed and the copper will generate heat, and this heat will pass quickly to the ice below it and it starts melting because there is increase in pressure. So you think like this, as the copper wire passes through the ice, the pressure on the top of that will decrease. So that water will refreeze back to ice. Like that, when the copper wire completely passes through the ice, the entire water will refreeze back to ice again. That is why the ice is not splitting. This process of refreezing, this process of melting of ice when the pressure is applied and refreezing of water back to ice when the pressure is removed, that is called regulation. It is because of this regulation that skating is possible on snow, because this girl is pressing the snow harder. When she presses the snow harder, due to the pressure the snow melts. Okay, due to the pressure the snow will melt, and when the snow melts, then what will happen? it becomes water, and water acts as a lubricant, and she will skate. And as she passes by, then what will happen? The pressure here became normal. So that water will refreeze back to ice again. So that is why you won't see water, but the moment when the girl presses the snow, that portion becomes water, and through that water she will just glide through it, skate through that, and as the girl passes by, this portion will again be of normal pressure, it will regulate. That means it will refreeze back to ice. So that's the condition. Okay. The same thing. So here we told about regulation. Same thing happens in the case of boiling point also. Because I told you boiling point will increase with increase in pressure. So you can think like this: you take water in a beaker and close it. First you open, keep it open, and then boil it. At some moment of time, you can see the water starts boiling. At that time, when we take the temperature, it will be 100 degrees Celsius. Now what you have to do is, don't switch off the flame. Without switching off the flame, you just close the water with a lid, airtight container. Make the lid airtight so that no steam escapes. We are continuously giving the flame, but still you will see that boiling stops. Why the boiling is stopping? Because we close the lid so that no vapor is going out. So the pressure will start increasing. And I told you, when pressure increases, the boiling point also increases. Understood? So the boiling will stop, and the temperature of the water slowly increases, and only when it reaches about 121 degree, it will start boiling again. Okay, it will start boiling again. So there also, what you are seeing, when we increase the temperature, boiling point will increase. Now you switch off the flame. So at that time the boiling stops, right? Now what you have to do is, the flame is now switched off, the boiling is not there. Now you open the lid. When you open the lid, the pressure is decreasing. At that time, boiling point also decreases. So the water is now attained a temperature minus 21 degree. Water has attained a temperature of 121 degrees Celsius. When we switch off the flame, the temperature comes down. It will become 120, 119, 118, 117. But it has not reached 100. Imagine, it has not reached 100. It has just reached 110. At that time, the flame is off. At that time, you are opening the lid. Then the pressure decreases, right? And when pressure decreases, the boiling point also decreases. So you can see, even though I am not applying the flame, the water will boil again, because I decrease the pressure. Water will boil again. So these are the conditions. This is just a reverse process of regulation. That is what I told you. Now just think like this: can we boil the water without heating it? Can we boil the water without heating it? That is also possible. What you have to do is, you just reduce the pressure. When you reduce, when you reduce the pressure, then the water can even boil at room temperature, or water can even boil at 5 degrees Celsius or 4 degrees Celsius. So you will see at 4 degrees Celsius, you will be seeing water is boiling, but when you put the hand will be very cold. Understood? Because we are not heating, we are just decreasing the pressure, thereby decreasing the boiling point. Okay. Now I am just taking 3 modes of heat transfer, just mentioning. The details of that is excluded from our syllabus. I am just mentioning 3 points. The first thing is conduction. Conduction is the mode of heat transfer due to the vibration of the particles in the medium, and conduction takes place only in metals. Metals are good conductors of heat. Now, what is convection? Convection takes place due to the transfer of heat by the actual movement of molecules. Example, when the water boils, water is an insulator. So, when water boils, what happens? We supply heat from the bottom. The water at the bottom will get heated up. The hot water is less denser, so hot water will rise up. The cold water will take that place. Again, that water will get heated up. It will rise. Cold water will take that place. Like that, the entire water gets heated up. That process is called convection due to the circulation of the molecules. Now, the third mode of heat transfer is radiation. Radiation means it is the process of heat transfer due to the actual transfer of heat waves, which is called infrared radiations. Example, the heat coming from the sun. There is no medium for the heat to transfer. Even if there is no medium, the light from the sun comes to the earth. How? It is transferring as heat waves, which are infrared radiations. So, without the presence of the intervening medium, you will be getting the heat. That is called radiation. We don't have to study all those things in detail, so I am just mentioning the name. That's it. Now, vaporization we have already studied. It is the transition from liquid to vapor. And boiling point at standard atmospheric pressure is known as normal boiling point. It depends on the nature of the substance and pressure. And we just now studied boiling point increases with increase in pressure and vice versa. I have given you the examples also. So, you can please note down those examples that I have told you. Okay. Now, this I have told in the previous section, but still I have just written it one more time. As the altitude increases, pressure will increase. So, water will boil at low pressure, at least like 70 degrees Celsius. So, cooking will be difficult at higher altitudes. So, you can note down that also. And sublimation. We discussed sublimation means transition from solid to vapor. So, in that process, both the solid and vapor state of a substance coexist in thermal equilibrium. Example, dry ice. Dry ice means solid carbon dioxide. That sublimes because it will not form liquid, it will directly go to vapor state only. Naphthalene balls, that will also sublimes to gaseous state. Okay, so that is about sublimation. Now, here I have told dry ice sublimes iodine. Iodine will state to the vapor state. Okay, so that's all about this chapter. This chapter comes to an end with this section. Hope you have all understood. Thank you.